how we can do this. How are we going to set up this first one? I want all, okay, Alec, get rid of that. Thanks. In here, no, I don't, lab's fine, but not in here. All right, first one, what are we going to do? Talk me through it step by step. I want the whole process here, because the process is important. It really, don't get in the habit of just trying to jump to an answer real quick. I mean, you got to kind of set this up methodically. What am I going to write on the board here first with this one? Okay, yeah, good. Set up the template. We know what the answer is going to look like. It's going to look like, if it works, it's going to work like that. Now, it's not always going to work. Sometimes things won't factor. That's kind of a next year issue. For now, they're going to. But next year, when they don't, we'll cross that bridge when we get there. I can set up the parentheses. I know it's got to look like that, and I even know something else. What's the first term in each factor going to be? X, yeah. I know those have to be an X because when I FOIL this out, and we'll review that here, not today, but later this week. When I FOIL this out, first times first has to give me X squared, right? The only way to do that is just X's. So that much I know. I can even know something else. Before I start thinking hard on this, I can still come up with one other thing. The two numbers that I have to find, first of all, multiply to what? 30. Say it again? 30. To 30. They have to multiply to 30 and add to 11, right? Okay, before we even start focusing on those numbers, I think it's helpful to just think about the signs. If the two numbers multiply to a positive, what can we say about their signs? They're either both positive or both negative. But if they're going to add to a positive, which one is it? Both positive. So you can even write down the signs of those two numbers. And now all you got to do is just focus on the numbers themselves. So what are numbers that multiply to 30 and add to 11? Okay, so we have 5 and 6, but that can get tricky. How could we, what if the numbers were bigger? I mean, 30 is not a huge, 30 and 11 aren't huge numbers, but they can be a lot bigger. So how could we go about a process here of, in an organized way, finding those numbers?
There's a way you can do it on the calculator.
There is a way, and I'll show that to you. There is a way on the calculator. For now, I want to just think about this using some mental math. How can we set this up so we can maybe, in an organized way, make a list of factors, how about, that multiply to 30 and add to 11? Yeah, we could do something like a factor tree. Let's set up two columns here. Let's set up a list of factors. And what do they have to multiply to? 30, right? We know they have to multiply to 30. So we may need to keep going, but I'll just set a couple of these up. So we got to find groups of numbers that multiply to 30 and add to 11, right? Okay. How about if we find numbers that multiply to 30 and just find their sums, and when we get an answer of 11, we're there, right? To be organized about this, though, here's what I like to recommend. And I'm sure it doesn't seem like a big deal with these small numbers, but what if instead of a 30, that was 244? And instead of an 11, that was 38 or something. Then it gets harder to do, right? So let's start with big factors. So we're going to start with the biggest factor of 30, which is 30. Right? You always start with the number itself. 30 times what is 30? 1. Okay. Now let's work our way down. If we increase this 1, does 2 go into 30? It does, right? 2 times what is 30? Right? Does 3? Yeah, 3 times. Okay, and we can keep on working down if necessary, right? Let's look over here and see what these sums are. 30 plus 1, 31, way too big, right? We want 11. 15 plus 2, 17, still too big. 10 plus 3, 13. But what do you notice here? There's a really important trend. As the factors get closer together, what's happening to the sums? They're getting smaller. Yeah. Okay. So that's kind of an important thing to remember. If you end up with a really small number in here, if b is a small number, then you know that the factors are pretty close together, right? So we'll keep going. Does 4 go into 30?
No.
Doesn't. Does 5? Yeah. 5 times 6 equals 30, and the sum is 11, so that's our winner. Right? Make sense? So then the numbers, we know what this looks like. Our numbers are just 5 and 6, and we're done. Okay? Questions? Make sense? All right. How about this one? First step, before we start thinking, first step, parentheses, good, we'll set up our template, so now we'll start to think about filling in the blanks. What about the signs in this case? What are they gonna be? Two negative, right? Because they have to multiply to a positive and add to a negative, so I know they're both negative. Now I just have to find numbers that multiply to 15 and add to 8. Well, we could make our factor list, but these are small enough. Maybe we'll just see if we can come up with these. The numbers multiply to 15 and add to 8, but are both negative. So I add the negative 8. Yeah, good. -3, -5. Good, got it. Okay, next one, set up the template. Okay, now this is a little different. This time, if the numbers multiply to a negative, what does that tell you about the signs?
One's negative, one's positive.
Good, one's negative, one's positive. Here's what I like to do with this. I think this is helpful. If one's negative and one's positive, what I always do then is I look at the sign of B. It's negative. Now think about this. If two numbers, one's negative and one's positive, if they add to a negative, what does that tell you about the two numbers?
Negative one's larger.
Yeah, okay, does that make sense? The negative one is larger. For example, if I add up -7 and +4, I'm gonna get -3 because the 7 was bigger than the 4, right? Make sense? So I always then like to put the larger, the negative one in this case, the larger one first. So it reminds you that the negative one is bigger. How much bigger? Now this is kind of optional, but some of you are just this is gonna click with some of you. If I add these together and I'm left over with -2, that tells you something else about it too. How much bigger was the negative number? For 2, make sense? Right? Because that's how much the positive canceled most of the negative, but the negative still had 2 left over, so it must have been 2 larger, right? That can be helpful when you're looking for those numbers. They got to be different by 2. What would they be? Yeah, there we go. -5, +3. The 5 is 2 bigger than the 3, right? Does that make sense? Okay. Down here, bottom one. Same kind of a deal. Multiply to a negative, so the signs are
One positive, one negative.
one positive, one negative. Add to +5, so which is the bigger?
Positive.
Positive. And they gotta differ by 5, so the positive one is 5 bigger. What would those be? Multiply to -36, add to +5. Yeah, that makes sense? 9, 4. Okay, got it? All right, so those are the easy kind. If A is equal to 1, all we're doing is just looking for the magic numbers that multiply to C and add to B, and that's it. Then we're done factoring. Okay, what happens though if we see something like that? How many of you have seen bottoms up before? Raise your hand real high if you have. Okay, good. Bottoms up is helpful. But do we need it here? It kind of looks like we do, right? Because bottoms up is what happens when A is not equal to 1. But I'm telling you, we don't need it this time. How come? What can I do here that makes this easy? It's always our first step. If A is not equal to 1, what we always want to look for first is this first step. As soon as somebody tells me. What do you think?
Cancel the 3s.
Okay, cancel, almost. We're not canceling the 3s. We're going to factor out the 3. This is, I think a good way to think about this is undistributed. We're going to see if we can factor out the greatest common factor, which means can we undistribute a number from all of the terms. In other words, what's the biggest number, if there is one, that goes into 3, 3, and 6? Well, 3. Good, so I could undistribute a 3. I'm gonna put the rest of it in brackets, because that's the part we're gonna have to work on, but the 3 is taken out front. What is left behind if we factor that out, or undistribute it?
X squared.
Okay, x squared, because we're just dividing each term by 3, right? Another way of thinking about that is 3 times what is 3x squared? Well, x squared, right? 3 times what is negative 3x,
Negative X.
right? 3 times what is negative 6?
Negative 2.
Okay, that's good. That just turned this from a hard-looking problem, from a potential bottoms-up kind of problem, to one that's the easy kind of factor. So you always look to do that first, every time. Can I factor out a greatest common factor? When I do that, it makes all of the coefficients smaller and it makes the problem much easier, okay? So now what? What is this gonna look like? If I write this, a template for this, I've got that 3 out front. It's part of the answer. It's gotta be there. What is this stuff gonna look like though when I factor it? Does it look familiar? Yeah, isn't that just gonna be our normal template, right? This is gonna break apart into a product of those kinds of factors. So now we just have to find numbers that multiply to what?
Negative 2.
Negative 2, add to
Negative 1.
negative 1. What are they? Numbers multiply to negative 2 and add to negative 1. So one's negative, one's positive, right? The negative is bigger. What are they? Yeah, 2 and 1, sure. Done. Okay. So it turned into an easy one when we factored out 3. All right, can we factor anything out of that one?
No.
We can't. So now we've got to go bottoms up. So let's go through the steps on bottoms up. Step number 1, I guess we'll kind of try to write these down as numbers here. So step 1, anybody remember? It's been a while. Remember what you do? Say it again. B over, well, that's different than I've done it. You might have done it a different way. When we're done, you can show me and I'll see if I like your way better, like we're down in the lab sometime. You remember? This is kind of the way I've always taught it. You find out what the product of A times C is. What is that?
Just kidding.
No. So it's gonna be the, what is it? Negative 18. You gotta make sure you get the sign in there, it's negative. And we wanna remind ourselves, what is B? 7. Okay, much like before, we're just trying to find magic numbers. We wanna find magic numbers that multiply to AC and add to B. And if we need to, we could make a factor tree here. Can we come up with those? Numbers that multiply to negative 18 and add to positive 7? Which one's going to be positive and negative, right? Which one's going to be bigger? Positive or the negative? Positive. Okay, so we got a positive one and a negative one. What do you think? So bigger positive number, smaller negative that multiply to negative 18, add to 7. Let's make a list. So we've got 18 times negative 1, 9 times negative 2, etc., right?
Yes.
What are these sums? That adds to 17. That's no good. Those add to
7.
bingo, right? That's it. So our numbers are positive 9 and negative 2, right? Okay, those are our magic numbers. So there's step 1. We got to figure out what are the magic numbers. There they are. Okay, step 2. Step 2, we're going to set up a template just like we did before. So step 2, we're going to kind of write the, what would you call these things? The prefactors or something. We're going to write them out as, just like we did before, like that. X plus 9 and X minus 2. Okay? There's step 2. step 3? Remember step 3? What do you do with A? I'll tell you, step 3. You're gonna take A and you're gonna divide each of those magic numbers by A. So that's almost all step 3. You divide each magic number by A, and then you reduce the fraction. So what am I gonna get then for that first factor? I get x plus, what is 9 over 6 reduced to? What's the biggest number that divides into both 9 and 6? 3. 3 goes into 9 how many times? 3 goes into 6 how many times? Okay, makes sense? What's the biggest number that goes into 2 and 6? 2. 2 goes into 2 once, goes into 6 3 times, right? Okay, now we do bottoms up. The last step is the easiest one. So last step is we just take the denominator of our simplified fraction and we go from the bottom up to the coefficient of x. So this looks like, then we're gonna get what, a 2x plus 3 times a 3x minus 1. And we're done. That's it. So once again, the steps, the 4 steps. Step 1, we're gonna find the magic numbers that multiply to AC and add to B. Probably the hardest step right there. Step 2, we're gonna write the initial factors where we just write, we add those to x. Step 3, we're gonna divide each of the magic numbers by A and simplify. Step 4, piece of cake, bottoms up. The bottom of the fraction and move it up in front of x, coefficient. Okay, try this. Everybody try this. What do we always want to look for first? What do we want to see first? Before we jump in and do something complicated like bottoms up, we always want to check to see what. Say it again. Okay, good. If I can undistribute something, is there a number that goes, is there?
No.
Nope, nothing. Okay, so we've got to do bottoms up. Tell you what, let's do. Let's just have everybody do step 1 and stop. So we're just, step 1, we're going to try to find the magic numbers. What's AC? -8, good. What's B? So what do we get? What numbers multiply to -8 and add to -7? -8 and +1. Agreed? So those are our magic numbers. Okay, take it on step 2. What was step 2 again? How do you describe it? step two is neat, yeah, step two is an easy one. We're just gonna set up those initial factors, right? I'll go back to the last slide real quick so you can see the template. Okay, that was step two. It's an easy one. Okay, step two is probably, you should be done. What's step two? Just x minus 8, x plus 1, that's an easy one. Okay, step 3. Here's my hint on step 3. Okay, step 3. We're picking out some people. Let's see here. Justin, what'd you do? It's the first part of step 3. What'd you do?
I divided by 4.
Good. Okay, we're gonna take the 4 down and divide each of the numbers by 4. Very good. Okay, what's next? What's next?
Simplify.
Simplify. Okay, what does this simplify to? -2. Ah, there's not even a fraction. So what do you suppose that means? We're done. Yeah, this one's done. This one just simplifies to x minus 2. Done. What about this one? Can we simplify 1/4? It's already simplified. So there's step 3. That was the easy one. What's step 4?
Put the denominator in front of the x.
Yeah, bottoms up. So there is no denominator here. It's done. It would be a 1, right? Doesn't change anything. Here the 4 goes in front of the x, right? Okay, and our answer is the quantity x minus 2 times the quantity
4x. +1
plus 1. That's it. That is so much easier than the alternative. Okay? Try another. AC, what do we get? Bailey, what's AC here? What'd you get for A times C? Okay, you want to help her out with that? 50, okay. Okay, what's B? Alec, what'd you get for B? -27. Okay, this is a little tougher. Did you come up with magic numbers that work? Didn't get it? So they got to multiply to +50 and add to -27, right? What do you know about the signs?
Negative.
Both negative. Okay, suggestions? Get them back, oh, back here, you get it?
-25 and
-25, -2, very good. So our magic numbers, -25, -2. Okay, we got them. There's step 1, done. Step 2, easy. We're just gonna set up the prefactors, right? Or initial factors, so we get x minus 25, x minus 2. Let's see, next step. Molly, what'd you get for your next step, for step 3? Good, divide both of the numbers by 10, and then we'll simplify. So 25 over 10 would simplify to what? Good, negative 5 over 2, because 5 goes into both of those, right? 5 goes into 25, 5 times goes into 10, 2 times. What about right here?
Negative 1/5.
Negative 1/5. Okay, so there's step 3. Let's see. Last step. Abigail, what'd you get for bottoms up? The last one. This is a fun one. This is the easy one. What do you get? What do we do? Last step. We got to get rid of those fractions. What do we do with the bottom of the fraction? Bottoms up. That's it. Perfect. Good. The 2 goes up there. So this becomes 2x minus 5. And where's 5 go here? Out in front. Sure. So this one becomes what? Perfect. You got it. That's it. Easy. It's not easy, but doable. Okay, we got just a little bit of time. This is going to be tight. Let's see something here. We're out of here in when? 9. Oh gosh, that's going to be hard to do.